Okay, hi everyone. Today we're going to solve another problem, that is LeetCode 134 gas station. Now this is a medium level problem, but I will say that it has a lot of learning to it and it's a very good level problem. And it has a very decent like to dislike ratio. So let's get excited for this problem and solve it. There are n gas stations along a circular route. So first of all, we are given a circular route and there are n gas stations where the amount of gas at the ith station. So there are n gas stations. So this is a circular route that we are talking about, and there are n gas stations. So let's say this is a gas station, this is a gas station, this is a gas station, and like this. Now every gas station has a gas I. Okay, so every station has some gas corresponding to it, and there is a cost array as well that is given to you, and it will tell you if you go from this station to the other station, what is the cost that is required to move from the ith station to the I plus 1th station. Now you begin the journey with an empty tank at one of the gas stations. So you can start with 0th, first, second, third, or any of the gas station, and you begin with an empty tank. Now, okay. So we are given two integers, gas and cost. That's obvious. Return the starting gas station's index if you can travel around the circuit once in the clockwise direction. Otherwise, return -1 if there exists a solution. Okay, so it's a simple problem. Well, this was the visualization of the gas of the route, but it's better to study the problem in a linear fashion. So 1 2 3, then you have 4, then you have 5, right? So this is the gas of the ith station, and ith station is, so is it zero based indexing? So we are index 3. Yeah, it's a zero based indexing. So you have 0 1 2 3 and 4, right? Now let's first of all try brute forcing it. So we need to form a circular route, which means that if I start from 1 and I travel all the way back to 1, right, which means I go to this direction, which means I go to this point, then I go to this station, then I go to this station, and then I go to this station, and then I obviously return back to 1. And what is the, like, with cost, and can I do it or not? So let's see. So this is gas, and then you have cost. The cost is 3 4 5 1 and 2. Fine. Now if I start from 1 to 2, what is the gas that I can have at station 0th station? I can have one gas. And what is the cost of moving from 1 to 2? It is 3. So if I have a car, let's say this is my car, this is my car, or let's say this is my car, or let's say this is my tank of my car, right? If I start at 1, if I am at 0th station, I will get one gas. But the cost of moving from 0th to 1th station, that is the first station, is this one, that is 3. So basically I will be having minus, so it will be -3, which is nothing but -2. Can I have -2 fuel in my tank? I don't think so, right? Which makes it impossible that I cannot even go to the second station. If I cannot even go to the second station, can I start at 0th station? No, I cannot. So I will say that at 0th station I cannot start. It's a very wrong observation that you have made. At 0th station you cannot start. Simple and stuff. Now you will check for second station. You will go to this one, then you will go to this one, and then you will go back, right? Let's see if we can do this. So now, because we are starting fresh at second, so gas tank is empty. Now I have this 2 second, and the cost of going from 2 to 3 is 4, which means -4. And this point I have -2 fuel. Again, -2 is a negative value. I cannot have a negative fuel in my tank, right? Which is why this index is also not giving me the answer. will also not be a starting station. Then I will be at 3. At 3, can I will be going to 4, to this 4, and then I will be, because it's a round trip, then I'll be going at this place, then I will be coming back and coming back at this place. I think in the previous dry run part, in the for the 2 second example, I have been just directly connecting it, ignoring the 0th station, but yeah, this is the correct way of doing it. So I'll be going to 3 to 4, then 4 to 1, and then 1 to 2, and then 2 to 3. This is the right way. But it doesn't matter, because if you are not going to have enough fuel for the first trajectory, right, for the first transition, then it's not making any sense if you want to complete the whole journey, right? Because you won't be having any fuel to go to the other stations if you are not going to the I+1 station. Okay, so now at third index, the fuel that you will have at third index at second station is going to be 3, and the cost is 5. -5, this will give you -2. Well, obviously we cannot have this, so this is also not true. Now we are at 4. One, so for 4 I can, from third station I can go to fourth, from fourth I will go to 1, from 1 I will go to this station, this and this, right? At this point, from 4 to 5, so from 4 I will have, at station third I can have 4 units of gas. I have 4 in my tank now, but the transition requires 1 cost, so 4 minus 1 is going to be 3. I can have 3, okay, it's fine, which means that I can make this transition. Now, can I go from 4 to 0th station? Well, let's see. From 4, from 4th station I will have 5 units of fuel, which means 3 plus 5 is going to be 8. And the transition is that from fifth to the second is going to be 2. You are going to have, your car will use 2 units of fuel in order to move from 4th station to the 0th station. So you will be subtracting 2 from 8, which is going to give you 6. Okay, it's fine. 6 is still a valid number of units of fuel that you can have in your gas. At least it's not negative, right? Okay, so from 0th index, can I go to this one? Well, we have the fuel that I will have at 0th index is going to be 1, so I will have 7 here. But the transitioning cost is going to be 3, which means 7 minus 3 is going to be 4. Well, it's still valid, right? I can still go from this point. So I will say that, okay, it's fine. I can still go from this point. Now I am at second index. Sorry, first station. From first, I have 4 units of fuel in my tank, and I will be making a transition, and this is the petrol that I will get. So the total will be 6, because this 2 is added with the fuel that is already there, that is 4. 2 plus 4 is 6, and the transitioning cost is going to be 4, so 6 minus 4 is going to be 2. So I have 2 in my tank now. Fine. 2 is still a valid answer. 2 is still a valid units of fuel, so yeah, it's not a problem. Now I will be going to this point, and let's see, we have another test. This is the last test that we have. If this will pass or fail, let's see. Now I am at this station, that is 4th, right? And at 4th, I'm not going to do anything. Why? Because I have finally came to the station that I was on previously, that I have started on, which means that this is my answer. And the station that you can start from and come back to that station is going to be your answer, and that is why this third index is going to be your answer. That is why our answer is 3. Now, doing this method in a brute force way, where we are checking if there's a circular path, if we can have a circular path between, for every index, is going to be very costly part, right? Because for every index, let's say there are n elements, for every element, for every index basically, you will be doing n work, which means the total work done will be n into n, which is nothing but order of n square algorithm. and this will be basically time of n square, and space complexity will be, yeah, auxiliary space complexity will be nothing, it will be constant. But time is an issue here. Why time is an issue? Because we have 10 raised to the power 4 as a constraint, and no, actually 10 raised to the power 5 as a constraint, and 10 raised to the power 5 will be 10 raised to the power 10, and this will give you a TLE. You don't want to do that. So let's see if there's any smart option to, if there is any smart way of solving this problem. Well, yes, there is a smart way, but it requires the concept, it requires a greedy technique to do it. And greedy techniques are very notorious to have, because they must have a proof. Otherwise, if your greedy technique doesn't have a proof for its working, for the algorithm, for the solution that it provides, then it's not a greedy algorithm, then it's just a guess. So we need to have a proof for this. Let's see what is the greedy algorithm that I'm proposing. I say that when I'm checking, so I should be checking for every index, right? So first condition for a greedy algorithm is going to be like this. Okay, so very first condition for a greedy algorithm is going to be that the total cost and the total gas that you have, the total gas that you can have from these stations should be greater than the total cost. Fine. Okay. So the total gas that you can have from these stations is going to be 1 plus 2, that is 3, 3 plus 3, that is 6, 6 plus 4, that is 10, 10 plus 5 is 15. So total gas is equal to 15. Now let's calculate total cost as well. So total cost is 3 plus 4, 7, 7 plus 5, 12, 12 plus 1, 13, 13 plus 2, 15. This is also 15. Okay, it's good. It's not a problem. If you have total gas, if your total gas is greater than or equal to total cost, if this is the case, then it's fine. But if you have something like this, that total cost is greater than total gas, no, then it's a problem. Why it's a problem? Because your total cost is greater than total gas, which means if it's a circular route, then starting from any index will give you a problem, right? And I will tell you why in the further steps, why this will be a problem, in because this is, we are going to use this concept in the proof. So the proof is, let's say I have this station, right? There are a lot of numbers and I'm on the ith station as of now, and there is some midway that is I plus kth station, and then you have a jth station. So you start from I to j station, right? You are going from these stations, you start from this and you end at this. Why did you end at this? Because it's not a circular route, obviously you still have these elements and you need to come back for the ith station, but you ended at jth station, which means that the total gas in tank is less than or equal to 0, right? Okay, so my proof says that if this is the case, then none of the elements in between of I and j are going to be a start station. Why is it so? Okay, so if I go to I and then I go to I plus k, so first of all, I was at I and then I went to j, right? How did I went to j? Because every point of this, every point, at every point from I to j, I was getting my tank value to be greater than or not equal to, actually greater than 0, right? That is the only possibility that I can actually travel from the station I to the station j. I was able to, I can afford to travel from station I to station j only because my tank value, only because I have some fuel in my tank, it was greater than 0. If I don't have any fuel in between, if I don't have any fuel in my tank in between, then I wouldn't be ending on j, I would have ended much earlier than j, right? This is a very simple observation. Okay, so this is one thing. Now if I say that j could also not be an answer, why? Because if I start with j, right? So I to j is failing. Then if I start with j, then I will go back. Let's say my this solution works out and it's good. And then I'm coming back, and at this point, the total gas will decrease. If the total gas will decrease and we have this thing that total cost should not be greater than total gas, then it will be a problem to start at j. I think this is a simple observation. We don't need much. Like, if you want to, you can obviously think about this one, but this is a very simple observation. So, which only left us with the second, that is the j plus 1th element, starting from j plus 1th to other elements. And if they are also showing the same tendency as the I to j elements, then they will also not be treated as same. Otherwise, j plus 1th elements could be our potential answer. And from j plus 1th element, I will check if I have a fuel or not. And let's say I reach a last point, let's say j plus 1th element. Yeah, I was having some tank value, and my tank value to this point is greater than 0. Then you will say that, do we need to come back? No, we do not need to come back. Why? Because I have already checked that the total gas is going to be greater than or equal to total cost. So if this part is positive, then it also makes sense that the part coming from this to this part will also be positive, right? Because there is some value in the tank that I'm taking at this point, because earlier there was no value because when I was starting from 0th, or let's say I was starting from I to j, there was no tank value. I was starting from 0, right? But at this point I will be starting with some value that I have achieved from j plus 1th station to the nth station. And from 0 to j plus 1th station, I will be having some tank value, and that tank value will give me a proof that because the total gas is greater than the total cost, and now I can be rest assured that coming from this route to the j plus 1th route, I will be covering the route because the total gas is greater than the total cost. And this part is also done, and this part is also done, so I will say j plus 1th is my answer. I don't even need to check it in a circular fashion to go back from 0 and check again. I can just check this part, and I can just rest assured that because total gas is greater than total cost, so it will give me the correct answer. So this was the proof. I think that the circular part could be confusing, but if you think about it, if you kind of imagine it like you have a car and you're going through stations, then you can easily understand that the whole thing makes sense, because this total gas part, the total gas is greater than total cost, is very important when you are checking it for the second part, that is a circular route, that is a circular when the car is coming back to the start station. So this was the proof. Let's see if we can get it done. So first of all, I will have total cost. We need to check this condition. If total gas is equal to accumulate. So in C++ we have this accumulate function, which is going to give us the sum of all the elements present in the array of gas and cost. So accumulate gas dot begin, gas dot end, and 0, that is the initialized variable. And you have int total gas, and then you have total cost is equal to accumulate cost dot begin, cost dot end, and then you have 0. Now there's a first condition. If the total cost, like this way, total cost is greater than total gas, then it's a false condition. We can never have a start station, and when we don't have a start station, we will be returning -1. So I will return -1. Now tank is equal to 0, because in the question it is stated that for wherever the station I'm starting from, I will have 0 fuel in my tank. And then you have a station number that you need to return, and let's start it with -1. Okay. Now for loop int I is equal to 0, I is less than, we don't have n, so we will create it. And int n is equal to gas dot size Now, so tank will be added with gas of I, the gas that I can have from the ith station minus the cost at the ith station, when we are moving to the I plus 1 station. So this will give me the residual gas that I will have at I plus 1th station, that I will have in my tank at I plus 1th station. Now, if the tank value is less than 0, then it's a very simple observation that if the tank value is less than 0, the station that I have chosen earlier to be my start station is not a start station. We cannot start from that station. So because of that, my station value will change to I plus 1 station. I will say that, okay, it could be the I plus 1 station, which is why this should not be initialized with -1. This should be initialized with 0, because 0 is my, because at very first assumption I'm saying that, okay, 0 could be my station. But then moving to further elements, I realize that this is giving me the tank value as -1, so I will not be choosing 0, and then I'll be choosing another element, and from this element, well, the whole another, like, similar to this proof, that okay, we will be checking these elements, and if this is true, then this is true. So station is equal to I plus 1, and tank value will be reset. This is equal to 0 because now we are starting at station I plus 1, and we will have 0 fuel in our tank, 0 gas in our tank. So this is there, and now we will return the station number that we have chosen to be our start station. Okay, it is accepted and it is performing all right. So now to the time complexity, how this greedy solution, like, why this greedy solution is fast, and what is the time complexity. So time complexity for this solution will be linear. Why? Because we are traversing the elements only once, and we are going in, this direction, so it's a linear time. And space complexity is constant, because we auxiliary space complexity is constant because we are not using any other data structure, any other linear data structure. We are using just couple of variables. And yeah, so this is the solution, and if you want to check the source code, you can find it in the description. If you want to try this problem, you can find the link of this problem in the description. And if you have any feedback for me, do let me know. Yeah, so thanks for watching. Have a good day.